It's just a continuation of what we did before. Okay, let's pray. Our dear Father, we thank you this morning. We are bound to start this class. Lord, may you guide us, protect us, be with our students wherever they are, so that, Lord, when the time comes, we can meet again. We pray for your mercies now and forever. We ask in Jesus' name. Amen.
Amen.
Okay. The problem starts with like a question that we are doing here. It's like we are trying to, because I talked of De Morgan's laws before. I give you De Morgan's laws. There are some laws that we call the laws of De Morgan's, which I think I had mentioned previously, which I expect you to check. So this is the question governs, is starting from these laws that we're calling De Morgan's. So like this question, though the question starts with something interesting, we can answer the question using the laws of De Morgan's and trying to construct the circuit that governs it. So when you have this problem, which is given here, the circuit looks like this. Remember, this is a multiplication. This is an AND gate, so we need AND gate here, which is this gate, but it's negated here. So this negation here is this one. All right, this negation is this one. Then we have the second gate, because it is a multiplication again, but before that we need a second gate, which is CD again, which is another multiplication. So this gate here, remember this is straight. If it was AND gate, it could have looked something like this. But now this is not AND gate, we're talking of it is not OR gate, it is AND gate. So this is the AND gate that we have here. And therefore with this straight line, it's defined CD. So again, it's negated here, which we have here. The two now, this part only is a multiplication. So again, we need another AND gate, which we have here. Now the whole of this gate now, the whole of circuit now is again negated by this big bar here. So this big bar, it means you negate again. And so this is the circuit. This is a circuit that corresponds to this gate. To this equation. This function is defined by this circuit. So now if we use De Morgan's laws, we can try to simplify this equation of this circuit or the function here to see whether we can get a simpler or a better way. There could be different ways that circuits can be, can be expressed. So using De Morgan's laws now, we are able to simplify this problem. What does De Morgan's law say? That if you have A, B, bar, for example, this becomes what? This becomes A plus B, you distribute bar to each. What happens is that now you are changing the dot or the multiplication, which is the AND gate, to become the OR gate, all right? To become the OR gate. That's what happens with the De Morgan's laws. Conversely, when you have A plus B, these are De Morgan's laws, which are complemented, you simply distribute the complementation. But now the multiplication becomes a dot, or the addition becomes a multiplication. So that's how this problem is expressed in terms of the gates, in terms of the AND and OR gate. So we try to simplify those ones. So you do the inner part first. You do the inner part first. I don't know whether this will work, but let me check. My bundle being given a warning on the phone. Let me see if the hotspot will work here. So if you don't get me, let me know, because I'm using now, I've switched to something different, which is a Wi-Fi, and sometimes it was not working. It's saying this is unstable. Okay. But if you don't get me, let me know. Then let me know your pleasure. Okay, so this is where we are now. So ignore this one. What is this one saying now? No people are writing things. I'm trying to follow and see whether I'm able to. Is able to join. Kevin Bengi. I'm trying to see if I can. Okay. Okay, so now we write the inner part, this one, in terms of the AND gate. I mean, using the De Morgan's laws, the OR gate, the AND gate here becomes the OR gate. You can see, then we distribute our equation on each of them differently. Then this bar, which was common, it still remains here.
Excuse me, sir.
Yes, this is Sule. Yes.
Mwalimu, your audio is not clear.
Yeah.
Your audio is not
Okay. And then I need to look for bundles now. Let me see if I can get bundles.
No, your audio is clear. I think they are the ones with the problem.
Oh, Janet Chochieng is saying you're the one with the problem.
Yeah,
Sule.
because your
Yes,
audio is I'm getting you clearly.
your audio is clear.
So what is not
Yeah,
clear?
like
Get clearly.
So what's the problem now, Sule?
the problem is on their side. They should check their side because yours is clear.
Sule.
Yes.
Sule. Am I audible?
Mwalimu,
Yes.
it is very strange that I can hear the yeah.
This person saying I allow them to join. No one have disallowed. If you join, if you send a request, I will just admit. So I've admitted. Who is this? Allow me to enroll the question. I don't know who is this one. I can see the name. I can only see the photo. So I don't know because I've allowed everyone who has this is Kimani who is now requesting to join. Is it Kimani or who is this one? There are some people who are chatting on the other side and they ask me if I can allow them to join, but I've not disallowed anyone. If you send a request, I just admit. So I'm trying to check if there's a problem on my side because no one is waiting. No one is on the waiting list. There's a list here called waiting. Okay, this must have been Kimani, I think, since now he has joined. Right, so where were we? I was trying to explain the expression of this, let me erase this one. What happened to this one? Comes it, you can't erase. Is it from my original notes or this one is on? Okay. Okay, this one must have been a different photo. Okay. Where's this one coming from? It looks like a constant. Where did I click? I don't see where I have clicked so that this one behaves as fun as it is behaving here. So it's not. How do I erase this one? Sule, are you there?
Yes, Mwalimu.
There's something
I'm
that has
here.
come on the screen here, which I don't see how it came here now. Hey, these things are becoming interesting nowadays. I think what I do, let me remove this one, then I share again. Let me remove this one, then I share again. This is the problem of sharing or what will the matter. Sharing, okay. I think it's okay now. Okay, I think it's okay now. Okay, I think this is where we are. So I'm trying to explain that we need to convert all these ones into the De Morgan's equations, which are equivalent. So what we do, we need to write the whole of this one. First of all, we start with the inner part. So what I think what I did. Okay. I had just lost the internet. I'm trying to see if I could get to them directly from them using my phone rather than this Wi-Fi thing seems to be the problem. Okay, so I was trying to explain where this one is coming from. Are you able to get me, or I need to check my settings? Okay, if you can get me, that's okay. Because the issue is there are those who could not. I'm saying I need to let you in. Who is this I did not let in? I have not disallowed anyone. Okay. I think I've admitted everyone. So that Morgan's laws, as I was explaining for those who are joining, they are given on the circumstance that you simply change the AND gate to become the OR gate, and the OR gate becomes the AND gate. So what happens? We handle this one as our problem. We handle this as our problem. So we put this one, we cut it into two because there's an OR gate, AND gate here. We make it OR gate. So this bar we put another bar here because there is, you know, I did say that if you have A dot B bar, it becomes A bar plus B bar. So this bar is the first one, which is common here. But you see now there was another one. So when this comes, they become 2. So therefore, that's why we have these 2 here. This still remains AB, then CD with 2 bars. But again, you know very well that A, you know, double bar is simply A. Double bar is double complementation is simply the value here. So double C is simply A. From the discrete setup, we have a double complement just gives you an A. So in this case, double bar gives you an A. And if it is AB, then it becomes AB. And that's why we have this AB plus CD. Therefore, this problem or this value here, which was X, we're calling this one now M. So this equation and this one now becomes the same. So using De Morgan's law, we are able to write this circuit differently. We are able to write this circuit differently. And that's how the De Morgan's laws, that's what I wanted you to have done.
Excuse me?
Yes, this is HP, who is this, Colonel? Yes. Garanti?
Yes, Malim.
Yes, your screenshot.
Yeah?
I'm seeing nothing on your screen.
That's Kerandi. You can't see the screen, so you can't see it moving?
Yeah. I'm seeing only your face.
There's no screen.
Ah,
You are not sharing your screen.
what happened? I shared. let me recheck. I thought I reshared the screen.
You are not.
Let me check. Oh. No, that's unfortunate. It ought to have been. It ought to have been shared. Oh, it's not being shared. Huh? Okay. Are you able to see it now?
Yes.
Yes.
Okay. I think there was a mix-up. I thought I had shared. You know, I'm hiding this thing because I'm working on a different. I need to admit everyone on the platform, so that's why I'm trying to work. I'm working on a different page, so if you can't see, you let me know. So this is what I'm saying, that I'm trying to explain where these values come from. This equation, which you're calling M here, is the same as this equation, which we called star. Using the De Morgan's laws, we were able to distribute this one. You know, it's like we are cutting here. We're not cutting per se, but you see, we are trying to put that, to change the OR gate or the AND gate to become the OR gate, which we have here. Then we distribute. Okay. People are joining still. So, and that's how the value comes into play. So don't ask where these values are all coming from. It's from that analogy that we are able to, you know. So in the same setup now, we are able to solve this problem. Are you able to solve this one? We can use the De Morgan's laws in the same manner. We try to solve this problem here, simplify. When the question that has been given here to simplify, to me, it becomes easier to use the De Morgan's laws and you combine with the laws that we had given before. So this A plus B bar, this one can be written as A bar dot B bar. Then we add to B bar, correct? Because this is A plus B bar, then we add to B bar. But using the laws, B bar is common, so we have the laws. Of course, you can decide even to factorize. You have B bar, so we have A bar plus what? Plus 1. From the laws, what is anything plus 1? I gave you the laws.
It's
A plus 1 is what? Yeah? Say something, Emmanuel? It's 1. This becomes 1. Anything times 1 is anything, so the answer becomes a B bar. So this equation simply simplifies to a B bar. You see, it simplifies to a B bar. That's how this equation comes here. In the same setup, you can simplify this one, which I have simplified here. You could see. So we distribute this dot, this becomes a dot, which is here, plus becomes using De Morgan's laws. Remember again, I'm using De Morgan's laws. I'm using the laws of De Morgan. So this becomes dot, we distribute the bar on each, the complementation on each of them. But again, when this is complement, you make them dot, this still remains. B bar again becomes dot is C bar. So B bar is just B bar. So you pick one. That becomes B complement, and therefore you have A bar, B bar, C bar, which you can draw a circuit if you want. You can draw a circuit if you want. All these are a multiplication. So we just have this A bar, B bar, C bar. There are different ways that you can do it. This is B, C. So we could put our complementation here on each of them, and this becomes your output X if you want to draw the circuit. Okay, if you wish to draw the circuit. We can use the same setup, but given the circuit now, how do we determine the circuit, the output of the given circuit? A certain circuit has been given. Are we in a position to determine the output? Notice this is given as 0, 1. When B is 0, B is 1, C is 1. So what comes as an output here? So when this A enters in this case, it's negated, meaning by the time it gets into the gate, it becomes 1 because it's negated. That means 0 complement is 1, and 1 complement is 0 because you know you negate each of the values there. So this becomes 1 here. 1 times 1 times 1, because these all of the others are 1, it gives you 1. So the output here is 1. The output here is 1. What about here? This enters as A. This enters here as A. And this enters here as D, which is 1. So 0 plus 1 is what? 0 plus 1 is 1. But it's complemented here. So 0, 1 complement gives you 0. So here becomes 0. So 1 times 0, which is these are an AND gate. This is an AND gate here. So this gives you 0. The output is 0. Given the variables, we are able to get the output, and this gives you a 0. So in the same setup, can we determine the output level for each of these one? When A is 1, B is 1, and E is 1, and C, D are 0, you simply put them here and carry out the operation. So we have X is equal to 0, D is 0, plus, this one, A is 1, plus 1 times 0, all of them are complemented. Then when you are done with that one, you multiply with E, which is 1. So what do you get here? We carry out 1 plus 1 is 1, 1 times 0 is 0, 0 complement is 1, so this becomes 0 plus 1 times what? 1, right? Times 1. This is 1 plus 0, then times 1. 1 plus 0 is 1, 1 times 1 is 1, so this is 1. So the output for this equation is 1. You simply put variables and check where there is a negation and thereof. Can we able to check?
Excuse me, sir.
Yes. This is a.
Yes, I'm not
Sangoro.
able to see your working area.
Can you see the screen moving?
No,
Who can see it?
The screen
I
is
can
moving.
see.
The screen is moving.
So what is the problem with the Sangoro?
It's moving.
Let him
So
refresh his phone.
what about when I write? Can you see it?
no.
Yes. Yes, I can see it.
Sangoro, now the problem is your sidebar. What do we do?
Let me log out and then I
Can you
log in
join?
again.
Can you join again? Most likely,
Restart your Nini.
that could be the problem. You can log out and then you join again, and then we see what happens. Okay, so you can be able to get the output on each of these variables. You try to check what will be the output. You can check what happens. So I've solved these ones in thereof. You can see how they are solved, and then you try to determine the result. I did share this one. Now, the next thing is what we call the determination, or how do we design the combinational logic circuit. We are able to design, because now what we've done is just what has been given, we are able to solve. What if we are now designing it? Are we in a position to carry out the design ourselves? Because as a scientist or as an engineer or as a technologist, as a computer person, you are supposed to design. You design something that you try to get the variables that you desire. One of the best ways to do is to use these two universal functions, what we call the min terms and the max terms. Now, the min terms are the sums of products, or what we call SOPs, and then the max terms are the product of sums, what we call the POS. So we have pose versus SOP. We have pose and versus SOP. Sum of products, meaning you have products which you are going to sum up. For example, you can have AB, these are products, plus CD, plus BE, something like that. These are products which you are summing. That's what we're calling the sum of products. But now you have products of sums. You can get the product of sums. For example, A plus B, all of this, you multiply with C plus D. These are product of sums. You see now you are getting the product. Product means multiplication and the sums means addition. Therefore, you are summing up the products. Here you are producting the sums. So that's where the words min terms and the max terms comes into the usage. Now, what is a min term? A min term is a product term combining each variable of the equation or its complement once and only once. The variable or its complement once and only once. The sum of min terms is determined as OR of end. That's what we are talking of. OR of end. These are end. Now we're getting their OR. OR means the addition function for each line in the truth table for where the output is 1. Where the output is 1. A max term is opposite of what we have said there. All right? So this is the sum combining each variable of the equation or its complement once and only once. So the product of the max terms require the sum of the complemented variable of each line of the truth table for which the output is 0. Here was 1, here it is a 0. So you are getting end of OR. Here you are getting OR of end. All right? Here it is end of OR. In the first case, it is OR of end. Gregory Oyangi, you're joining for forever. Are you joining or you already joined? Some people join with more than one account. So Gregory Oyangi is on joining here forever. It's not joining. Gregory? It's gone. Okay, it's gone. Okay, so that's what happens when it comes to design. And the problem that I did send is that we try to carry out a practical problem that we can design on ourselves a problem so that you see how the variables work. And so this is the problem that I did send. This is the problem that I did send here. And we are able to check and see if we are able to given. So this is the problem. I'm calling it problem 6 here, but you can ignore. Church, are you joining us multiple or now? The 2 accounts. Okay, I hope she's going to join. So this is what is given as an equation. So this is what given. We want to design it. Now you check this equation contains 3 variables, A, B, and C. A, B, and C. This equation contains 3 variables, A, B, and C. I'm saying we start at the reverse, but you can ignore that. You need to check the combinations, what comes into the mind first. So firstly, you need the 3 variables. If it were on a practical board, I could have shown you, but now this is another board because I could have done the problem differently so that you see the combination. But first of all, you need A, B, and C. You need to have those as a setup to start with. And therefore, the combination of that, these are 3 variables. So the number of possible subsets are given as 2 power n. These are 3 now. In this case, there are 8. So we expect 8 combinations. And how do we carry out 8? The first of all, you have zeros, 4 zeros, then 4 ones. Then they reduce in powers of 2. So divide by 2, you get 2, 2. 2 zeros, 2 ones, 2 zeros, 2 ones. Then now you divide by 2, you get 1. So it means they will be alternating as 0, 1, 0, 1 in that case. So for C, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 1. If you check each line, there is no repetition on each of the lines. There's no repetition. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Those becomes the output on each level. Those become the outputs on each level. So next, what we do is to get the complementation of each. We get complementation of each of these variables. What does the complementation here mean? The complementation means we get B bar, we can get A bar, and we get C bar. The order doesn't matter as long as you combine them. Luckily, the book is ruled, so you can follow each line correctly. So because we need them, we have A bar here, we have C bar, we have B bar. So we need those bars. So you check what is given. Otherwise, if there were no bar for each of them, or at least one of them, you just ignore it. But since we need a bar there on each of them, at least there is one in the original equation, we have to account for each of them. Now we get the parameters, each of them. Currently, we have A bar, C bar, C already, we have them. A bar is here, C is here. So we don't need that, but we need A, C bar so that we can add later. So before we add, we need A, C bar. And this is A, C bar. What does this mean? You look at A and C bar. You compare each variable on A and C bar. So 0 times 1 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. That's how those variables are actually got. 1, 1 is 1. So you check each line and you get these outputs. Then from there now, since we have A bar, we have A bar, C, and AC bar here, we can now add them, and this is what you get. You just add. Remember addition, I did send you the notes before. Anywhere there is a 1, the answer is 1. 1 plus 1 is 1, 1 plus 0 is 1, 0 plus 1 is 1. So if you check off these combinations, the 3 of them, you're bound to get this one. So this, we are done with this part. Next, we multiply with B. B is this one. All right, B is this one. So what we're calling B here. We multiply with this line here. That's what we're multiplying with. So each of this one we multiply. So it is 0 times 1, you get 0. 0, 1, 0. So all the variables here, they come as a product of each of them. And that's how you get this variable here when you multiply. Then you need A, B, C, A bar, C bar. This is a product now. You need the product A bar, A, B bar, C. And that's when you get it, you get this one. Try to follow. If you can't check, you let me know. But this is what you get. Then now finally you multiply. You add this part and this one. You add these two, which I have added here. This is a continuation. The space became small, so I could not write this side, so I continue down here. So it is this 0 times 0, you get 0. No, plus, sorry, 0 plus 0, you get 1, 0. 0 plus 0, again, you get 0. 1 plus 0, you get 1. And the whole thing continues like that. You get all the variables here. You get all the variables when you just add all these ones. Wherever there is 1, of course, the answer is 1. Wherever there is 1, the answer is 1. So this is 0, but this is 1. That's why we have the 0, but we have 1s there. So from there now, we need to get the min terms. We need to get the min terms and the max terms. We need to get the min terms and the max terms. And that's where the term, min terms, and the max term comes. What are min terms? These are the sum of products which you get and of or of end, sorry, or of end. The max terms, we need and of or. That's how we get the min terms and the max terms. So where the product is 1, the output will be called the min term. For which the output is 1, the variable will be called the min term. That's what we say. Where the output is 1, then it's called the min term. Where the product output is 0, so we have the max terms. And that's why now, if you check here, we expect to have the min terms in this level. Where there is 1, we expect a min term. Where there is a 1, we expect a min term. Where there is a 1, we expect a min term, 1 min term. All others are max terms. So what happens then? The question now comes, and that's where the designing comes. How do we get a 1 on this variable here? How do we expect this 1 here? What possible combinations on the original circuit plus or its complement to get a 1? You can get this is line 1, 2, 3. Line, the third line, because that's where we get it. The third line is this one. So we are talking of this line. This line. This is where our problem lies. This is where our problem lies. How possible are we to get a 1 on this combination? We need a complement, because when it is A, this is 0. Remember, these are products. So we need a complement so that it can be 1. That means all this must be 1, 1, 1. How do we get 1, 1? We need a complement, which we have here. We need a B. B is 1, so we need a B without a complement because it is 1. Then we need a C complement, which is here. And that's how this becomes A bar, B, C bar. The second is the next line that follows immediately, which is this one. How do we get the variables without, the values that will give us a 1 in this level? The values that will give us a 1, it's A bar because it is 0, then B is okay, then C because C is not complemented. It's 1. So that's why we have A bar, B, C. So you can follow the same pattern to see how these other values come. It's in the same manner. But when it comes to the max terms, it is the values where you have 0. What are the possible combinations that will give me a 0? Like in the first case, for example, we can get a 0 because we are adding. 0 plus anything is anything apart from when it is 0. So all of them should be zeros. All of them should be zeros because 0 plus 1 will definitely give us a 1. So we expect an output in the case that it is a 0. What does that mean? We check where these are zeros. So that means it is A, B, and C. So the first case, it is A plus B plus C. This will give me a 0, which we have here. Here, the second line, we expect A, no, the second line is here. A, change this one to something, okay. This is second line. So we expect an a B, but a C is 1. If we add 1, we shall have 1. So we have to complement it. So C bar. So that's how this becomes A, B, C bar, so that we can have 0. In the same manner, this one will give us 0. So for us to get now the sum of products, we add all these terms. Addition, sum of products. These are products, but now we add them. That's how the addition has been carried down here. This is an addition. This plus this plus this plus this plus this. But for us to get SOP or POS or the product of sums, we multiply these ones. That's how POS becomes the product of these, of those ones. That's how the product comes into play. The next is semantics, simplification, as you deem necessary. So we are simplifying this one by the standard way of using the laws that I did send before. How do we do this one? All right, there are many ways. You can just follow what I've done here. If it's okay with you, you can just follow the way I did it if you find it okay. So what happened here, but I don't mean this is the only way. There are many ways that you can do this one, but this is the way I did it. You can combine, we can pair. A bar is common, right? Pick where the A bar is common on the first case. Here, this and this. So we can pair this one so that we work it as an entity. And here is common. Here is, no, I think I did this one. You can ignore this one. I think I did this. I combined the other two. But I'm not saying this is the only way. There is other ways that you can do it. So that the A bar is common. So we have A bar out. We have B, C bar plus BC. All right? So again, you can factor out B, or I could factor AB. I think I could factor AB, A bar B out, A bar B out to make it easier, so that I have C bar and then C. C bar plus C is what? It's a 1. I think it's a 1 from the laws that I gave you. C bar plus C, this is a 1. So the all of this is 1. Anything times 1 is that anything. So we have A bar B, and that's how this comes to be A bar B. I let this one remain, so it is the remaining here. Then again, I took AB out. AB is out. We have it into C bar C plus C. Anything C bar plus C is 1, or anything times 1 is AB, so this becomes AB. That's how this becomes AB. Then I did pick the law. There's a law that I'm using here, which already you have, that A plus A bar B is A plus B. I sent you this law. You have it. You can check in the axioms that I did send. You can be able to see this one. A plus A bar B is equal to A plus B. So in the same case then, I pick the B here. This and this. Okay, I think no. Let me combine this and this one. This and this. Because these are values which are commutative, you can combine. So that B is common, I factor out B. A bar plus A is 1, so anything times 1 is B, so this becomes B plus. This is just rearranging this one. Instead of B bar to be at the middle, becomes the first one, then I can use this law. And so this becomes B plus AC. B plus A, because this is my AC now. All of this is my B. This is my B here. This becomes my B. All of this in this equation. But now it is AC, so it becomes B plus AC. And that's how that equation becomes B plus AC. B plus AC. The question? So far, a question? Diana Mboya, do you have a question? Eunice Rasugu?
No, I have no question.
Kampicha, do you have a question?
Yes. No.
Okay, who is this? Felix? Felix Kimutai. Yes.
Yes. So in any case, the product of sum and sum of products should give us the same answer.
Correct. Correct. The POS and SOP are identities. What we are saying, the result from the lookout, they may not be the same. They may not be the same from the look. But when you simplify, they should be able to agree. Actually, when you simplify this equation, you should be able to get this one. You should be able to get this one. So I can give you that as an assignment. Just for you to check. I don't mean it is an assignment to Andy. Can you try to simplify this problem? This one. What is it? This one. Can you try to simplify? Someone is saying I let them in. No one is out. No one is yet to be admitted who have not admitted. Can you try to check whether this equation can simplify to be this one? Because the three SOP or sum of products must be equal to POS, must be equal to the original equation. They are identities. Of course, when they are written, they are not. But when you simplify using the laws, they should be identity. They should be identical. No one is on the waiting list. So this person, or is in another group. I cannot see someone who is waiting. What is your pleasure is 12:08. Is there someone with a class? Can you spare some extra 10 minutes or you have a class?
Yeah, we have a class, sir.
You have a class, Galoro? Are you sure you have a class or bana? Unajua kuna watu wanataka kwenda tu.
Kuna wale.
Kuna wale wa kuendanga tu. I thought you could spare 10 minutes if you don't have a class, but if genuinely you have a class, that's okay. Nyota, Josephat, do you have a class? This Nyota is Church, Agnes, do you have a class? Nyota, you can speak. It's okay. Is this Nyota listening or is reading BBI? I could be busy. Kimani, do you have a class? Lena, Modomi, you have a class?
No. No.
Which class is this that you're having?
Human biology.
By who?
By Ramesh.
Oh, Professor Ramesh. Okay. So the class has started or not yet?
I don't know even.
Or you can't follow I thought there's a way that you can follow. Oh, so I think we cannot, I thought I could continue.
Hello,
But actually, yes.
I had a question.
Yes, Bengi.
In the above equation, you had something like B plus complement.
Which one? This one or which one?
And then plus S.
Is it this one or which one?
The one that you are using. Yeah, that one, down.
Down.
When you scroll down.
I continue further down.
Yeah, this one. There. The one that is B plus B complement plus AC. So I think the answers will be AC.
Where are we now? You're talking of this one or this one?
The one you are pointing there. The answers will be AC.
So B plus AC, or you're saying here?
Go up.
I'm
Yeah,
up
there,
here.
there. When you simplify B plus B complement is equal to same as to 1. So the answer should be AC.
Okay, let me see. Where are we? We are here. Okay. Just this line?
Yeah.
This line?
Yeah, B plus B complement is the same as 1. Yeah, there.
Which B? No, I think you are out. We are combining this and this, and then we are combining this and this. Okay?
Oh, okay.
Yeah, that's what I did. This one is maintained. That's what it is here. It's the same. This one I did not touch it. Yeah. That okay?
Yeah, it's okay.
Okay. Yes, just Fatnyota. You have raised up your hand. Oh, he's gone out. He's coming back now. He's raising up and hand here. Okay. Yeah. So I wanted to just I give you as an assignment to check. But if you look at it, I have already solved it here. It's already here. You just follow and see if you can check. This is the equation that I'm asking you to do as an assignment. But actually I've verified it is actually true. So the problem comes. Design the logic circuit. These are how the questions are put. Design the logic circuit for the following designed output at all levels. So already you are given the output here. You're given the output here. So you're supposed to design the circuit. You're supposed to design the circuit. I think this one will mess it up. But I think I can erase it. The highlight is not working. I thought I could highlight it. It's not color that looks nice. The highlight is not working on this one. I don't know why. This has no value at all. So are we able to design the equation at all levels? You're given A, B, C, then the output is given as X. This is output. So how do we design now? Is this member of the class or what? Let me check. Hello?
Hello.
Yes. Sorry, I'm in a class. Can you call me later? In a class. Okay, let's continue. That one is just a call from another quarter. So what I'm trying to say is that not all the times that you need to put A, B, I mean the complementations, but of course, as you start, you need those A complement, B complement, and C complement. But as you continue with working, you will know it within your mind that what kind of combination that will give me these variables here. What kind of combination that will give me these variables. So here we can talk of min terms, or let me call them the min terms here. Then we can call the max terms on the right-hand side. The min terms are where the values are 1, where the max terms are the values where they are 0. Of course, there's another one here. So what values will give me 1 here? Now tell me, what can I use on this combination so that I get a 1 here? And remember, these are products. A product, it means all of them must be 1 for you to get a 1. Yes,
the complement.
The complement. So it becomes A bar, B bar, C bar. Here, Diana Mboya or Sangoro, you want to say something?
Yes.
Yes.
A bar,
B bar,
and
C bar, and C. Correct. So these are the values. Here, it will be A bar, B, and C bar. So that we can have 1. Here it will be A bar, B, and C. Here it is ABC. What about the output now, where there is max terms? For you to get max terms when this is 0, we need A bar plus B plus C. Here it is A bar plus B plus C bar. And here is what? A bar plus B bar plus C. So those are the outputs. So for us to get now sum of products, SOPs, for you to get SOP, it means what? The value X will be given us the sum of products. You add all these ones. You add all these ones. Add them. Products. These are products, you add them. For you to get POS, product of sums, it means what? You multiply this times this times this. The question continues. Show that the equation for the SOP is identical with that obtained from POS. Verify the equation, draw the circuit. That means what the values that you get, you need to simplify. Showing means simplification now. Simplify this one and see whether you can get identical value as this one. That implies the way we did here. Try to see whether you can simplify. SOP, the way we did it, until you got B plus AC, the same as B plus AC. Try to check if you can get the same value. So that's how you design. That's how you design. Of course, it is already solved here. It is already solved, but I want you to follow. Don't necessarily follow blindly, because sometimes these things are tricky. I was able to show that it is A plus AC, AB plus AC plus CB, which is the same as the value here. I was able to show, but I want you to follow, because the method of solving is not necessarily the same. Sometimes it varies. How come these are 4? Were they 4? No, I think this is for the second problem. This is for the second problem. The first problem, I think, has not been solved. This one has not been solved. Number 1 has not been solved. I think this is for the second problem. 1, 2, 3, 4. Yeah, this is for the second problem, because there are only 4. So the first one, you check it. The first one, you check it. So you can make it as a weekend homework, just to check, so that you are able to follow. By the time we meet on Monday, you are able to see whether that's true. Then the second question here: design the logic circuit that has 3 inputs. This question was not there. This is part of solution. Design logic circuit that has 3 input A, B, C, and whose output will be 1 only when the majority of the inputs are 1. This is the solution. This is the solution. This was solved. It was not part of the question. The question is, design a logic circuit in which the output is 1 when the majority of inputs are 1. Of course, this question I started reverse so that I can, instead of 1 being down here, see normally the trend is that 1 are down, but here 1 are up. But it's the same thing. By the end of the day, you're 4, 4, 2, 2, 2, 2, 1, 1, 1, 1, 1. All right. So the X is when majority are 1. These are majority are 1, so it is 1. Majority means in the case the things are 3, majority is 2. Okay? So 2 here gives you 1. This is 1 and 2, so they give you 1. Majority here, they are zeros because this is just 1, so this is 0. Because majority is 1, when majority, it's a 1 when majority is 1. In this case, majority is 0. That means it is 0. Majority is 1, it is 1. Majority is 0 because 2 are 0. Majority is 0 here. You know, majorities are all of them are 0, so it is 0. So this will give me the min terms. Where there is 1, they will give us min terms. This will give me max terms. That's why we have them here. You can check this correction here. This is A plus B plus C. So you need to check where there is a bar or where there is no bar. Like this one, I think there is no bar here. Okay. So check, because that's how the equation is given. Then the solution I've given, then the circuit is given here. This is the problem that I did send you earlier on. If you follow, I did send you this one. The first equation I just picked, simplify using De Morgan's laws. Anyone who encountered a problem on this one? Bengi?
No, so okay.
You okay? All right. The question continues. Construct the corresponding circuit for each of the following expressions using AND and OR gates and inverters. This one, inverters are not gates. These are not gates. Then we have what we call NAND gates, NOR gates, and where appropriate. The AND gate, NAND gate, it's the not AND gates. So this is an AND gate. This is a NAND gate. This is an AND gate. This is an AND, NAND, not AND. This N stands for not AND. Just to show not, you put complementation. NOR, it's OR gate. You'll forgive my drawing, but not OR, it means this one. So this is an OR gate. This is not OR, NOR gate. That's where this NOR comes. So you try to check this one and try to see whether you are able to. This is what we call the alternate symbols. The alternate symbols are actually not gate and NOR gates. So this one we can ignore it. I think I need to send you a note for this one, because I just want you to work out this one. You can ignore this one. There are some notes that I need to send for this kind of problem where you have alternate symbols. We have symbols and then we have alternate. Then you can prove these equations are identity. That means simplify the left-hand side to equal right-hand side. Simplify, that's what this means. Simplify until the right equals left, all right? In other words, means until you get something like x equals x. But for now, you see they are not equal, so we are not sure. This one, show that this can be given as this one. Simplify this one until you get this value. Simplify until you get that value. For the following desired output at all levels, design the logic circuit by determining the equation using the min terms and max terms. So this equation given, it's given here. So this the output is given like the one that we did on this, the first case here, this one. So you do this one and check if you can follow this one. So first of all, start with this one. If you can do this number 2 and number 1 and you can follow 2 because 2 has been solved, then make sure that you can check this one because it's in the same manner. First of all, you use the min terms and the max terms. Then you show that the equation is obtained from some product equal to that of that. So you need to simplify. First of all is to get the equation. Equation is just direct, like this one. The equation is just this and this one. And this one. These are just equations. Then now you prove, you simplify until you get this one equals the all of this one. So the second part asks you to simplify. That's what you're getting here. Then now, draw the circuit. Draw the circuit. With the value that you get, you can draw the circuit, like this one. We drew the circuit here when we've already solved the problem. Finally, you verify by constructing a truth table, all right? So after you've done the circuit here, I mean the last value that you've got, you verify by constructing a truth table for the obtained equation. So when you get that equation, can you draw the truth table? What is the truth table? Something like this. Because the equation will have A, B, C. Then have the truth table and see whether it will correspond to these values here. Okay, check whether it will correspond to these values. That's what I want you to check. That will be the assignment for the weekend, just to check something that you can ponder. So let me know in case you encounter any problem that you need clarification during your time of endeavor. I'm willing to explain further.
Excuse me, sir.
Yes.
The truth table that you've told us to draw on the last part.
Yes. Yes.
It like the one you drew here up, the x is equals to b into a complement plus c plus a complement plus a
like
c
this
complement.
One, like this one. So we are just trying to verify, to check whether the values that you get will correspond to these ones. That's what we're trying to check, what the values will correspond to these ones. Of course, you can put those complements and all that, but by the end of the day, you need the output, the final output. You know, the equation, assuming, for example, the equation will be x, just an example, the equation will be like a, b bar, c, for example. So this equation that you drew, meaning you start with a, b, c, then b complement, then you multiply them, which will be your x. That's what we mean by the truth table. So it is like this one. It's like this one. Because this is what was given, but you get the whole table until you get these values here. But
yeah, that's the table I was referring to.
Yeah, it's something like that. But now, first of all, you have to simplify to get the variables. Then after now, you start with A, B, C. If they are complements, you get the complement. Then if they are pluses, something, for example, if they are pluses, then you add them. So it depends on what will be given or what you will get as a result. Okay? Then you let me know. But we need to agree. We need a mid-semester exam. We need to agree. Which I should send. I'm trying to consult. Yesterday, I did ask my chair, do we need this exam with a lockdown browser, or we simply give a subjective exam? I'm yet to get the final remark, what is expected of us. So, but I think next week, maybe on Monday, I should give you a mid-semester. If it is an objective, I give you subjective, I'll give you a timeline and say within maybe 2 days or so, you should have submitted the mid-semester exam. I'm told the exams are starting on 15th. I have one chapter to go on K-maps. But before we go there, the issue is not completion of the semester. The issue is the completion, is understanding even that small thing. Can you understand that small bit? So make sure that you follow even those little things that we've done before we go to those advanced K-maps. We need to look at the Kanak maps, which I think I'll prepare notes and try to send to you later. These notes were being recorded, so I will post them on the YouTube, and then I'll send you the link where you can access on the YouTube right after the class. For those who attended, who left the group for the classes, they can come to the group, to the e-learning. They will get the notes, the link, and then they can go to YouTube and they get the link there. I'll put it on the YouTube just after this class. You can always access it there at your free time. Otherwise, thank you very much for extra time. We have given extra 30 minutes, but because the notes will be given online, you can always follow at your free time. For those who are on and off, you can join, you can get a link after this class, and then you are able to.
Excuse me, sir.
Yes, this is Sangoro.
Yes. Are we able to get the course outline? Because some of the previous classes did not find some of us when we had, by then we had not registered.
The course outline?
Yes.
Did you get all the notes that I sent?
I didn't get some of them.
Those are things that you should have asked someone, or you could have asked me earlier to send. Otherwise, it could have been easier that way. I thought I shared the course outline. What happened? I did not share the course outline on YouTube. I mean, on e-learning.
I did search for it, but I did not find it.
Because I thought my first lesson, okay, I think we can have that conversation elsewhere, because I wanted to end this one so that that does not become part. So where do we chat now? Do we chat on the group? I'm trying to see, because when I end this one, it will just start converting directly to the, but I don't want this to be part of the notes.